All right, good morning, Townview. Let's go ahead and get started. We're going to be going over yesterday's review. So this exam, it says units 1 and 2, but this review goes over mostly unit 1. Hold on one second. Yeah, this goes over mostly unit 2. This exam is going to have just a little bit of unit 1 questions just to make sure that it's a formative assessment, which means it goes over everything. So let's go ahead and go through these. So one chemical property of matter is what? So we know boiling point is physical, density is physical, texture is physical, reactivity is going to be the only answer that makes sense here. So that's that one. A neutral atom loses 2 electrons when it forms a bond. The atom is now what? So a neutral atom, let's say it started off with 10 protons and then 10 electrons. And then it says that it lost 2 electrons. So now it's got 8 electrons. So if it's got 10 positive charges, 8 negative charges, what kind of charge does it have left? This is going to have a positive charge. And things with a positive charge are going to be positive ions. We also refer to these as cations. And the T resembles the plus, so that's an easy way to remember it. And a negative ion is going to be an anion. So a mixture is uniform in composition. It's said to be homogeneous. That's just definition of homogeneous. Heterogeneous is going to be non-uniform. A compound is chemically bonded, and chemically bonded is a compound. The principles of atomic theory recognized today were conceived by who? So we've never actually talked about Avogadro, so you should go ahead and cross him out. So Bohr, he gave us the electron cloud. Rutherford gave us the gold foil experiment, which discovered the nucleus. And then Dalton, he gave us the postulates. He's the one who came up with the original atomic theory. Not the fire, earth, and wind one, but the one that came after it. And there were some parts that were wrong, and I guess that's what this one is. So Dalton's atomic theory agrees with modern atomic theory, except for which statement? So all matter is made up of small particles. We know that's true. Atoms cannot be divided in any reactions. Atoms of the same element are chemically alike. That's true. All atoms of the same element have the same atomic number. We know that's true as well. So atoms cannot be divided in any reactions. So the fact that he said that atoms are indivisible, we figured out that that's true with the Hadron Collider. And we talked about that in class. So an example of an extensive property, this is a property that does depend on the quantity. So as the quantity increases, this thing should increase. So in the case of density, it doesn't. Boiling point also doesn't. Color doesn't matter depending on quantity. Mass does change depending on the amount you have. So mass is going to be the correct one for this. Experiment with the cathode rays led to the discovery of, so this was J.J. Thomson. And he discovered the electron and told us that it was negatively charged. And just, you need to associate these 3 things. So the cathode ray, J.J. Thomson, and electron. In Rutherford's experiment, most of the particles did what? So Rutherford's experiment was the one with the lead box. And in the lead box, he had a radioactive material that was shooting out into a sheet of gold foil. And he found that most of the particles went right through. And what he discovered in that was that all the mass of an electron is going to be, all the mass of an atom is going to be in the densely packed nucleus. And so to answer this question, they didn't bounce back, they weren't absorbed by the foil, and they didn't combine with the foil. They passed right through it. Because most particles fired at the metal foil passed straight through, Rutherford concluded that atoms were mostly empty space. So none of these are true. Which part of the atom has a mass approximately 1/2000th of the mass of a common hydrogen atom? So what is a hydrogen atom? A hydrogen atom is 1 proton. It doesn't have any neutrons, and then it's got 1 electron. So 1/2000th of a common hydrogen atom. This is something small. We know that it's not a proton. We know that it's not a neutron, so it's got to be an electron. So if we say that 1 proton is equal to 1 AMU, 1 AMU, And then 1 neutron is also 1 AMU. 1 electron is going to be about 1. It's going to be about 1 over 1400 AMU. So it's very small in comparison. A horizontal row of blocks on the periodic table is called what? So here we're talking about the horizontal rows, and we call those periods. John Dalton is given credit for being the first modern chemist to introduce the idea that matter is composed of atoms. However, not all of Dalton's ideas came out to be true. Which concept in Dalton's atomic theory is now known to be incorrect? It's that atoms cannot be broken down into smaller particles. It's the same question we answered a few minutes ago. All isotopes of hydrogen contain what? So if they have, in order to be a hydrogen, it needs to have 1 proton. That's what you need to know about this one. If it's got more than 1 proton, then it's not hydrogen anymore. A positive ion is known as what? So this is going to be a cation. Remember, the T means positive, and then anion is a negative ion. The most characteristic property of noble gases is that they are unreactive. That's why they're called the inert gases. Argon, krypton, and xenon are what? So that's Ar, Kr, and Xe, and these are all noble gases. A negative ion is known as what? This is an anion. Calculate the average atomic mass of the hypothetical element of the following 2 isotopes. All right, so this one has a mass of... All right, so this is not a real atom. It's just something made up. But you need to know the formula that we use to calculate this. So it's just going to be mass times abundance plus mass times abundance, and then we're going to divide by 100. So in this case, it's going to be 602 times 42.75 plus 618 times 57.25, and then we're going to divide by 100. So I'm going to do that on my calculator, or I guess I could use this calculator over here. So 602 times 42.75, that gives us this number. We divide by 100, and then that's 257.355. And then I'm going to do it to the other one. So 618 times 52.25, which gives us that number. We divide by 100, and that gives us 322.905. And then I'm just going to add the first one that we had, which was 257.355, which gives us 580. Our answer should be 580. Actually, no, that makes no sense. Did anybody solve this and get something different? I'm going to pause. Within a group of elements, as the atomic number increases, the atomic radius does what? So within a group, they're talking about going down a group. So as the atomic number increases, the atomic radius increases. And that's because every time we go down a group, we're adding an additional electron shell. So we're adding an electron shell every time we go down a group, which means our atomic radius is going to increase. Within a period of elements, as the atomic number increases, the atomic radius does what? So going across a period, as we add more protons, we know that we're increasing the nuclear charge. And if we haven't talked about this before, we've been calling it the Coulombic charge, so the charge between the protons and the electrons. So this charge, we've been calling it the Coulombic charge. And as we add more protons, we know that the electrons come a little bit closer. So this is our Coulombic charge. We also refer to this as nuclear charge. And you need to know this because I promise this will be on the test. That's not how you spell nuclear. Is it? I don't know. So as we add more protons, our nuclear charge increases, which causes the radius to decrease. So just know that this is called the nuclear charge. So chlorine has an atomic number of 17 and a mass number of 35. That tells us that it has 17 protons. It's also got 17 electrons. And we're just going to have to do 35 minus 17 to give us our number of neutrons. So 35 minus 17. And that gives us 18 neutrons. And that's going to be this one right here. The total number of protons and neutrons in the nucleus of an atom is its what? That's going to be our mass number. And you need to know this because you're going to have multiple questions about this. So the mass number is the number of protons and neutrons. And the average atomic mass, this is the average of all known isotopes. If you don't know this, I would write this down. But the average atomic mass, this is the one that you see on the periodic table. There will be a question about this on the test. And you need to know that the average atomic mass is the average of all the known isotopes. The mass number, that's just the number of protons and the number of neutrons. You're going to see both of these on the test, and you have to be able to differentiate between the two. So the mass number is always a whole number. The average atomic mass is never a whole number. The region outside the nucleus where the electrons can most probably be found, that's called the electron cloud. All naturally occurring isotopes consist of, a naturally occurring element consists of 3 isotopes. The data on the isotopes is below. So we're just going to have to plug these into our equation. It's going to be 46.972 times 69.472. That's going to be plus 48.961 times 21.667. And you're going to see 4 questions just like this on the test, so be ready for these. And then 49.954 times 8.8610. So I'm going to plug these into my other calculator just because it's a little bit faster. So 46.972. Actually, this calculator's bad. I'm just going to use it here. 46.972 times 69.472. That gives, we got to divide by 100. And that gives us 32.632. Then we'll plug the next one in. 48.961 times 21.667. Divide by 100. And that gives us 10.608. And then our last one is going to be 49.954 times 8.861 divide by 100. And that gives us 4.426. And then we're just going to add all those together. So plus 10.608 plus 32.632. And that's going to give us 47.666. 47.667. That's going to be our closest answer right there. Let's move on. Another average atomic mass. So the atomic weight of naturally occurring silver. From the data, calculate the percent of... All right, so the atomic weight of naturally occurring silver is listed in the handbook as 107.868. From this data, calculate the percent of 107. You're actually not going to see a question like this on the test, so I'm just going to go ahead and skip this one. But, yeah, I don't think we need to go over this. An atom is electrically neutral when the number of protons and electrons are equal. So if your positive charge and negative charge are equal, that is a neutral atom. The elements in group 1 are also known as the alkali metals. So this is group 1, alkali earth, that's group 2. And then the P block is considered the nonmetals. And then the halogens, that's group 17. So Mendeleev noticed that properties of elements usually repeat at regular intervals when the elements were arranged in order of increasing. So remember Mendeleev, he was the father of the periodic table, and he originally lined everything up by atomic mass. The nucleus of an atom has all the following characteristics, except it accounts for nearly all the atom's volume. So we'll come back to that one. It's very dense. We know that that's true, so that's not the correct answer. It accounts for nearly all the mass. We know that's true, so that's not the answer. It's positively charged. That's true, so it's not the answer. So we have a densely packed nucleus, and then we have a bunch of empty space where the electrons hang out. So so the nucleus does not account for all the volume. A majority of the volume is the electron cloud, which surrounds the nucleus. Ions are atoms with unequal numbers of protons and electrons. So if you got 10 protons, 8 electrons, that's an example of an ion. And, yep. So an isotope of uranium-235 has 92 protons and 143 neutrons. Therefore, its mass number is what? We just got to add these together. So this plus 92, which gives us 5. And then 235 is our mass number. An atomic number of nickel-60 is 28. How many neutrons does that isotope have? So nickel-60, that tells us that its mass is 60. And its atomic number is 28, which means the remainder will be our. So it's just going to be 60 minus 28. Which gives us 32, and that's going to be our number of neutrons. To which group do fluorine and chlorine belong? These are the halogens. They're in group 17. That's F and Cl. How many electrons are there in an ion of phosphorus with a charge of 3 minus? So we're going to look at phosphorus on the periodic table. So phosphorus is 15, which means if it were neutral, it would have 15 protons, and then it would have 15 electrons. So if it's got a charge of -3, that means it's got 3 extra electrons, which means it's got 18 electrons. If it had a charge of +3, then you would subtract 3 electrons. An element has two naturally occurring isotopes. What is the average mass of 45.677? The first isotope has a mass number of 45 and percent abundance of 67. What is the percent abundance of the second isotope? So if our first one has a percent abundance of 67, we know that our total has to be 100. So we're going to do 100 minus 67, which leaves us with it's going to be 33. So Rutherford's gold foil experiment is famous for showing which of the following to be true. Electrons are negatively charged particles. No. Electrons move around the nucleus in set paths called orbits. No, that was Bohr. The nucleus is extremely dense, and most of the atom is empty space. That's the true one right there. And atoms cannot be subdivided. No, that's unrelated. How many protons are in an atom of lithium? So lithium always has 3 protons. If you look at the periodic table, it has an atomic number of 3, telling you that it has 3 protons. What is the average atomic mass of element Q if element Q has 3 isotopes with the following measurements? 59 with an abundance of 15. So let's just go ahead and plug this in. So we got 59 times 15 plus 60 times 55 plus 30 times 62, and then we're just going to divide by 100. That's going to be 8.85. And then 33. And then we're just going to add these together. So plus 33 plus 8.85, which gives us 60.45, and that's going to be this one right here. If you don't know these calculations, make sure to spend a little bit of time on them. Which scientist is given credit for discovering the electron? That's going to be J.J. Thomson. He had the cathode ray experiment. Which of the following elements, which one would have the smallest atomic radius? So you just want to remember atomic trends. And so if this was our periodic table, we know that the largest element here, the smallest is over here. And in this case, it's going to be fluorine. So fluorine is in this corner right here, and it's the smallest element. And that's if we exclude the noble gases. We know that neon is smaller than fluorine. We know that helium is smaller than fluorine. But we don't usually count the noble gases when we're talking about periodic trends. And here, they're not even answers, so fluorine is going to be the smallest. Lithium is all the way over on this side, and we know that lithium is larger, but we'll just go ahead and stop there. Of the following elements, which one has the smallest atomic radius? Is this the same question? Yes, it is. So again, that's fluorine. But if we could change the question up a little bit. We could just make this largest. So for the largest, we're going to look at our periodic table. So lithium is over here. Fluorine is over here. And boron is over here. And then nitrogen is over here. So the largest in this case would be lithium, if we were talking about the largest. And the way to remember that is the farther it is from fluorine, the larger it is. The closer it is to francium, the larger it is. Which of the following elements would have the lowest first ionization energy? So you need to know what first ionization energy is. Ionization energy is the energy required to remove an electron. And the closer that element is to having all 8 electrons, the more difficult it is to take an electron away. So this element here, this is a noble gas. This is argon. So argon, because it's a noble gas, it's very difficult to take one of these electrons away. So this has the highest ionization. This is a group, this is going to be chlorine. So group 17, also very high ionization energy. So this one is going to be the second highest. And that leaves us with element B and D. So both of these they have low ionization energies, but the farther an electron is from the nucleus, the easier that electron is to take away. So because this electron is so far from the nucleus compared to this one, so this one is right here, this one is farther away. It's farther away from the source that's holding it in, which means this one is easier to take away, which means this has the lowest ionization energy. I know some of y'all got this right doing this on your own. Good job. But that's how you would solve a question like this. You will see one just like this on the test. So correct answer here is D. As one moves from left to right within a period across the periodic table, the electronegativity of elements encounters tends to, so electronegativity goes up. And the reason it goes up is the smaller an atom is. And we know as we move to the right, elements get smaller. So the smaller an atom is, the better it is at stealing electrons, which is what electronegativity is. So we're going to put increases for this one. So as one moves from left to right within a period across the periodic table, ionization energy also goes up. And it goes up for multiple reasons. One reason is it's closer to 8. So it's closer to 8 electrons, which means it's more difficult to take one away. And then another reason is that they're also smaller. So the smaller an atom is, the more difficult it is to take an electron away. So this is also increases. As one moves down a group on the periodic table, atomic radius does what? So as you go down a group, you know that you're adding shells, and as you add shells, elements get larger, so atomic radius increases. As one moves down a group on the periodic table, ionization energy, this goes down. So the farther an element is from the nucleus, the easier it is to take its electrons away. So ionization energy decreases as you go down a group. As one moves down a group on the periodic table, electronegativity does what? So electronegativity also goes down. So the smaller an element is, the higher its electronegativity, the easier it is for that element to steal electrons. So if we're talking about fluorine, here's fluorine right here, here's chlorine, and then here's bromine. Which one's going to be the best thief at stealing electrons? It's going to be fluorine. It's very small, and it can get in and out, take its electron real easily. So electronegativity decreases as you go down a group. Of the following elements, which one has the smallest radius? It's going to be the one closest to fluorine. So let me look at my periodic table. So we have fluorine, chlorine, and then oxygen. And iodine is under bromine, so bromine and then iodine. So which one has the smallest radius? This one has the largest radius. This one is just a little bit smaller than iodine, but we know that every time we go down, we're adding an extra shell. The smallest element, because fluorine is not on this list, the smallest element is going to be oxygen. It's got 1 shell. Actually, it's got 2 shells. And then chlorine has 3 shells. And it having that extra shell makes it much larger than oxygen. So the smallest element here is going to be oxygen. Of the following elements, which one has the largest radius? That's going to be the one farthest away from fluorine, the one closest to francium, which is going to be cesium. So cesium is just above francium. It's a very large element. Of the following elements, which one has the largest radius? This is just a repeat question. So if the question was which had the smallest, these are all group 1 elements. So this is the first one, and then so you have hydrogen, and then you have lithium, and then you have sodium, and then you have potassium, and then rubidium, and then cesium. So cesium we know is the largest. Hydrogen up here is going to be the smallest. It's got only 1 shell. All the other ones got more. Of the following elements, which one has the greatest ionization energy? So the elements with the highest ionization energy are going to be the ones closest to fluorine. So in this case right here, the one with the highest ionization energy is also going to be the smallest of the bunch, which is hydrogen. The element with the smallest atomic radii are found where? So atomic radii, we know that as you move down and to the left, elements get larger. So the smallest elements are going to be in this corner, and that's going to be the upper right hand. And that's it. If you guys have any questions or want to do tutoring, make sure to contact me. But that's going to be it for me. Have a good day.